afternoon, and for the last, but not the least, of the topics of part 7, that's power. Power is another thing that we use in everyday life, another word that we use in everyday life that doesn't mean the same as it does in physics. Power in physics has a very specific definition. It is the rate of change of energy. So mathematically, it's written very simply. That's it. That's the change in energy. This is the form for the general power, so the rate of change of energy going to an object or taken from an object. However, we can find the rate of change of energy, which is really just the work done on an object over some amount of time. We can find what the power is for the work done by any force we have. So we can write it specifically for one thing. If we have some force F that does a work W during a displacement D, then there is a power related to this force because there is a work. That whole thing happens during a certain span of time. Nothing is instantaneous, even if we'd like to be able to teleport. So we can rewrite this and find directly what the power of a force is by just a bit of derivation. So another way of writing it is the change of work over time, the instantaneous change of work over time. Because remember that work and the displacement and the force don't have to be uniform. So for this we need to go to the general case where the work can change. However, even if the work can change for a very, very small increment of time, this holds true. This is the whole concept of calculus 1, of derivatives, of infinitesimal calculus. Using the definition of work, then we're going to say, but let's ignore the fact that the force can change and just consider the displacement. We have a constant force. Then we can distribute the derivative to the dot product. And if the force is constant, the leftover term, that becomes F times the derivative of the displacement over time. Well, by definition, that's just the velocity. So if you have a force acting on an object, and you have the velocity of that object, this assumes a constant displacement and a constant velocity. We would need to get into more integral calculus in addition to all of this, and it becomes quite a pain and quite a mess. But if we have a constant force and a constant velocity, at least uniform, the power of that force for that object is F dot V. That's it for part 7. I'll see you in part 8.